In this short video, I'm going to be discussing how a surface plus point probe rides over a far surface volumetric indication that has slight surface irregularities on the probe side. So this thin aluminum plate, I took a drill bit and I made a slight drill hole there, but it's not a through-wall hole, it's just partial. But it's very clearly a volumetric, there's some metal missing. Now if I turn this thin plate over, there's a slight area, fraction of a millimeter, that I can catch with my fingernail where the metal sort of pushed up from the drill bit pushing in on this side. So now I'm going to take plus point probe. See the line on there? That's to help you maintain proper orientation when you're scanning. First you'll scan one way, then you'll rotate the probe and scan another way. Now how this plus point probe works is I'm gonna null on a piece of, this is thicker aluminum that I'm nulling on here. And to show this effect, I'm gonna have to change the angle a little bit. But let's see here. What I'm gonna do is vector one set of flaws to go down. So the axial EDM notches are facing away from me. So when I have my reference line pointing to the left and I scan to the left, with the null it again. Come on now. Axial flaws go down. See that's an axial flaw. Now if I rotate my cal standard 90 degrees and then scan past them, the indications go up. That will be null again there for you. So they go up. If I turn the cal block, you're going to go down. So that demonstrates this is a plus point probe. Axials and circs are vectored in different directions. And if you go over a volumetric flaw, and if there's no surface irregularities, I might have to reset my angle on this one a little bit. So we're just going to go over that little volumetric wear where there's a slight area sticking up. And what I'm going to do is just change the angle of this a little bit. This makes it a little easier to see here. I'm just going to start scrolling over that small area. Okay. Now right here, there's your null. You can clearly see the dual polarity. Steam generator world, this is a common type of signature when you're crossing over a volumetric flaw. You'll get the dual polarity. So you look where your null point is, and then when you scan over the material at that volumetric location, you'll get deflections in both directions. But it all depends on how your coil is passing the flaw. There's dual polarity there. But now let's go scan on the edge of this little area. Right on the edge. It's not super difficult to get a single polarity response. It just depends on how you hit it. When I tend to stick off to the side of this thing, I gotta keep doing it to hit it right. getting it. That's a one-directional response right there. I'm right on the edge of that flaw, and with the plus point probe, it's only going straight up. There's absolutely no down to that at all. This could be mistaken for a circ, when it's really just the edge of a volumetric with a little bit of a liftoff variation going on. But if I try to really carefully center over that flaw, now you start getting into the, well, they're still one directional. All go in the same direction. There we're starting to get some dual polarity up and down. There we go. That's giving us dual polarity. So it all depends on how your plus point's riding over your flaw and if there's any liftoff.